Hello everyone. We are Team Tech for Impact from STM College of Engineering, the Harvard. Imagine entering a confined sewer chamber without knowing whether the air you're breathing is safe or lethal. This is not a hypothetical situation. This is the daily reality of sanitation workers. The first and most critical issue is manual entry into toxic environments. Workers step into confined spaces without prior knowledge of gas concentration levels. Invisible gases like methane or hydrogen sulfide can cause unconsciousness within seconds. Secondly, there is no real-time monitoring. Once a worker enters, there is no continuous monitoring of vital parameters such as heart rate or oxygen levels. If something goes wrong, detection happens only after collapse. Another serious gap is the absence of exposure tracking. Toxic gases exposure is cumulative, yet no system records how long or how frequently a worker is exposed. Long-term health risks remain undocumented and unaddressed. Further, there is no institutional accountability. Without environmental and physiological data logs, safety audits become impossible. Responsibility becomes unclear and preventable incidents repeat. The result? Alarmingly high accident and fatality rates in municipal sewer systems. The core issue is simple. Current systems are reactive. They respond after danger becomes critical. What we truly need is a proactive system, one that detects risk before it becomes fatal, monitors workers in real time, logs exposure data, and ensures accountability. Because safety should not begin after a tragedy, it should prevent it.
Today, I'm presenting a system, an intelligent real-time safety and monitoring architecture designed to protect sanitation workers working inside confined sewer environments. Sanitation work is one of the most dangerous occupations. Workers are exposed to toxic gases, low oxygen levels, flooding risks, and structural collapse, often without proper monitoring or immediate help. Most accidents happen because workers enter the manholes without knowing the actual conditions. What we understand is that the real problem is not just hazardous conditions, but the lack of visibility and decision making before or during the entry. Our system focuses on preventing accidents before they happen instead of reacting after. Our solution is a multi layer safety system that continuously monitors the environment, the worker, and the overall risk conditions and supports real time safety decisions. The system consists of a pre-entry sensing unit, worker wearable devices, and an edge gateway and a central monitoring system with supervisor application. All these components work together to create a complete safety ecosystem. Before a worker enters, we perform a structured pre-entry safety check. For this, we use a motorized probe system that is lowered into a manhole. This probe measures gas concentrations such as hydrogen sulfide, methane, carbon monoxide, and also checks oxygen levels. Since gases settle at different levels because of their densities, the system takes reading at multiple depths instead of a single point. Based on these readings, the system classifies the manhole as safe, caution, or blocked. This step ensures that no worker enters blindly into a hazardous environment. Once the worker enters, continuous monitoring becomes important. For this, the worker is equipped with wearable devices. This includes a panic button, motion detection, and basic status monitoring, including the helmet. If worker presses the panic button or remains inactive for a certain time, the system immediately identifies it as a risk condition. This ensures that even if the environmental sensors miss something, the worker is still protected. All the data from the sensors and the wearable devices is sent to an edge gateway, which acts as a local processing unit. This gateway is very important as it works even when there is no internet connectivity. It collects data using Bluetooth or Wi-Fi, processes it locally, and makes immediate safety decisions. If the network is not available, the gateway stores the data locally and synchronizes it with cloud, and once the connection is restored, we'll be able to see the data reflected onto the cloud also. This ensures continuous operation without dependency on the internet. At the core of the system, we have a safety decision engine. This module analyzes gas levels, worker status, and exposure time. Based on predefined safety thresholds, it determines whether the situation is safe, caution, or block. It also tracks how long a worker is exposed to unsafe conditions and generates warnings if limits are exceeded. If the situations worsen or no response is received, the system automatically escalates the alert. This ensures that there is no delay during the critical situations. All the system data is stored in the cloud database, such as MongoDB. This allows real-time synchronization between the field devices, the supervisor application, and even the dashboard. Supervisors can monitor gas levels, worker status, alerts, and operations in real time through a mobile application or a dashboard. This provides complete visibility and control over the operation. As a future enhancement, the system can also suggest biological treatment methods to reduce gas generation in high risk manholes. This is not part of the real time safety and is not also part of primary solution, but still helps in long term prevention. Overall, our system transforms the manual, unsafe operations into a structure, monitored, and data driven process. This prevents unsafe entry, enables real time monitoring, supports quick response, improves accountability. Our goal is not just to monitor conditions, but to prevent accidents and ensure safety and dignity of the sanitation workers. Now, I will explain how the subsystems interact with each other to ensure end-to-end safety. Our system works as a connected network where each module exchanges data, decisions, and alerts continuously. First, the pre-entry safety module performs initial risk assessment. It collects multi-level gas and oxygen data and sends it to the edge safety engine, where the environment is classified as safe, caution, or block. This decision is shared with the supervisor module to allow or stop entry. If unsafe, it directly triggers alerts through the alert module and stores the data in the system. After entry, the environmental sensing module continuously monitors gas levels. It sends real-time data to the edge safety engine for evaluation. If thresholds are crossed, it sends hazard signals to the alert module. The same data is shared with exposure module and even the supervisor dashboard and stored for logging also. At the same time, the worker monitoring module tracks worker safety. Variables send panic signals, motion status, and presence data. Emergency signals go directly to the alert module, while activity and time data sent to the exposure module. Worker status is also sent to the supervisor module and edge engine for decision support. The alert and emergency module acts when a risk is detected. It receives inputs from both environmental and worker modules and triggers alerts to the worker and supervisor. If not acknowledged, alerts are escalated. It also sends emergency control signals like evacuation warnings also. The exposure and risk module calculates risk based on time and hazard levels. It receives data from environmental and worker modules and sends warnings to the alert module if exposure limits are exceeded. It also provides analytics to the supervisor module and supports the edge engine for better decisions. At the center, the edge safety engine processes all incoming data. It receives inputs from pre-entry module, from environmental sensors, from worker monitoring, and also exposure modules. It performs real-time classification and triggers alerts and sends decisions to the supervisor. Since it works locally, it ensures real-time operation without the internet also. The supervisor module provides visibility and control. It receives safety decisions, alerts, worker status, and environmental data. It can initiate pre-entry checks and acknowledge alerts. Finally, the data and cloud module stores and synchronizes all of the data. It logs sensor data, alerts, and worker information, which can later be used for further work. If connectivity is lost, data is buffered and later synchronized because the edge gateway works without internet connection also, and later when the connection is restored, the data is synchronized to the cloud. Overall, all subsystems interact continuously to create a coordinated safety network that enables the real-time monitoring, decision-making, and emergency response.